Screencast 20.15, redox reactions and spontaneity. You'll recall that we can establish whether an electrochemical cell is spontaneous or not by calculating the free energy. And if it's negative, it will be spontaneous in that forward direction. That's equal to the negative value of the number of electrons involved times the Faraday constant times the electromotive force of that cell. And if it's under standard conditions, and it usually is, we can write E0 and look them up in a standard reduction potential table. There's the number of moles of electrons. The Faraday constant is defined as 96,500 joules per volt mole, and since a coulomb is a joule per volt, that's equal to 96,500 coulombs per mole. We have another value for free energy, well, another way of calculating standard free energy, which we've used before. It's equal to the negative value of the gas constant times the Kelvin temperature times the natural log of the rate constant. Since these two things are equal, we're just showing both of these here, we can combine them, leading to this calculation here. But before you really start applying this, realize that a lot of this stuff is going to cancel, because we've got a number here, we've got a number here, and we can go ahead and write the standard conditions, which was a number here too. All sorts of units will cancel here, leading to one giant number, right? I mean, we've got joules divided by joules. We've got 1 over Kelvin times Kelvin, that cancels. And we've got moles divided, 1 over moles divided by 1 over moles, that cancels too. The only thing that does not cancel is volts, but take a good look at that. That is 1 over 1 over volts. So it's not really on the bottom, it's on the top. The whole thing can be simplified to somewhere. Oh yeah, units are canceling. Everything but the volts here. And N. And volts is on top, N is on the bottom, and this all breaks down to 0.0257 volts divided by the number of electrons times the natural log K. Now that's a nice simple formula to use. If you prefer to use the regular log, base 10 log of this thing, there's a different value for it. You can use either one of these, and these are, these are useful formulas. Take either natural log or the log, your choice. So let's take a look and evaluate these terms in terms of positive and negative and the rate constant. There they are, all shown together. Use whichever one's most useful. I'd probably memorize this one, and this one, but it's up to you. And like we've done before, when the free energy value is negative, it's spontaneous reaction with a favorable rate constant, meaning higher than 1, and it'll go in the forward direction. When it's 0, well, you're at equilibrium at that point, and so K is defined as being 0, and the reaction is at a tipping point. You can't, it's not quite going in either direction, or you should say it's going in equal amounts in both directions. And finally, if it's positive, that's typically thought of as a bad thing. It's going to be non-spontaneous in the forward direction, an unfavorable rate constant, but it would be spontaneous in the reverse reaction. This is Screencast 20.15.